What's up, guys? Welcome to my new video. Here I'll be showing you guys how to get the values of these trig ratios. I'll show you how to get the answer to this, and this, and all of this. You'll be able to recall it without referring back. You'll be able to recall it without having to draw the triangle. But I'll first show you how to draw the triangle, because it's useful to know it in order to be able to recall this without drawing it. So, if you want to know how to find these, let's get into the video. The first thing you need to know is how to draw the triangles. The triangles, the two basic triangles for the ratios, né? There are two triangles. There's this triangle, the one that has 1, 1, and square root 2. It's the same as the one we did in grade 12. Everything is the same, except we represent the angle in radians. Now, we used to have 45 here, 45 degrees there, when we had this triangle. And so, another thing, you just need to know that there's 1 and 1 there. You need to only know that there's 1 and 1, because this comes from these two. So if you forgot what's at that side, if you know it's 1 and 1 because it's 45 degrees and 45 degrees, then you know 1 squared plus 1 squared should be equal to the radius squared. And if you do the Pythagoras for that, you get the square root of 2. Alright, so now we used to have 45 degrees there. If you have 45 degrees, how do you convert it to radians? What you do is multiply by pi divided by 180. And 180 is 9 times 2. And 9 times 2 is 45 times 2. Which means 45 degrees times pi divided by, I said this is 9 times 2, which is 45 times 2. This gives us 90. This gives us 180, right? Because then this will cancel that. And then you have pi divided by 4, meaning that's pi divided by 4 radians. So 45 degrees is pi by 4 radians in this triangle. Or anyway, pi divided by 4, pi divided by 4. If you know the angles, you can already tell what the ratios will be. But now, I want you to be able to imagine the triangle in your head. You should be able to imagine the triangle. You should be able to see. With 45 degrees, it's better because sine and cos are the same. So you just know that whenever it's pi by 4, and either sine or cos, it's just going to be 1 divided by square root of 2. It's just going to be 1 divided by square root of 2, because the opposite side is 1 for this one, and the hypotenuse side is square root of 2. So you should be able to imagine this part. And then we'll go to the second triangle. The second triangle has 1 here, has square root of 3 here, has 2 here. For this one, you only need to know that there's 1 and 2 at the hypotenuse. You need to know that there's 1 and 2 in the hypotenuse, and then you do the Pythagoras theorem. It'll be 4 squared minus 1 gives you 3, then you put a square root. Okay, so set this angle has to be bigger than this one, because the subtended side, no, I don't know if it's subtended, if that makes sense, but either way, it's because the opposite sides should correspond to the angles. in terms of size. Now, the bigger number here between these is pi divided by 3. Therefore, pi by 3 should be there. Pi by 3. Then pi by 6 should be here. Okay. Now, you can, if you know this, you just need to remember in your head while you're imagining the triangle. You just need to remember, if you have something like sine pi by 3, you just say, okay, the opposite side has to be the larger side between 1 and square root of 2. That means it has to be it has to be square root of 2, square root of 3. The opposite side has to be the larger number between square root of 3 and 1. The larger number is square root of 3. And then you divide by 2. Then for cos, the adjacent side has to be the smaller number between this and this. You just imagine it like that, but I'll get to it. You get into it. Then here's the second way, or the last way for this video for memorizing or getting the angles. It's the functions. If you use the functions, you can get the remaining angles, such as pi, 2 pi, and all that. So this is the sine graph. This is a sine graph. You can put on the labels, but it's not important for now. This is pi. This is 2 pi. This is 0. This is pi by 2. This is 3 pi by 2. Okay, halfway is pi because the maximum is 2. The end is 2 pi. Halfway should be pi. Half of this should be this. Then the average of this should be this. And then we also have the cosine graph. Here, okay, here is 2 pi. And then here is halfway, so it should be pi. Here it should be pi by 2. There should be 3 pi by 2. Okay, now if I'm given a ratio such as sine pi by 6, I'll say, okay, this exists in the triangle that has the hypotenuse is 2 and it has a side that's square root of 3 and another side that's 1. Pi by 6 is the smaller angle. So if it's sine, the opposite has to be the shorter side. The shorter side is 1. The hypotenuse side is 2. Okay. Now, if you're given cosine pi by 6 maybe, you say, okay, this exists in that triangle again, but now we're saying cosine of pi by 6. For cosine of pi by 6, we know that the opposite side first has to be the shorter one because this is the smaller angle. So the opposite side is 1. That leaves the adjacent side to only be square root of 3. That's divided by 2. Right? Now, say maybe you are given sine pi by 4. Given this, we say this exists in the triangle that has 2 equal angles and 2 equal sides. Sine and cos in that triangle are the same and they are both 1 over square root of 2. The opposite side is 1. The hypotenuse side is square root of 2. So that's 1 over square root of 2. Okay, I think you get this. Then if you are given maybe sine pi, maybe, what you do is you refer back to the graphs. Sine pi is at the center, of the sine graph when you're moving from 0 to 2 pi. There, the sine graph is at 0. It's touching the x-axis, or the, I don't know if there's such a thing as a theta axis, but the x-axis. So as you can see here, at pi, this is 0. That's how we recall this. Say 0. And then now you're done. You should be able to get most of these, because you just have to imagine the graph. For cos, you have to say -1 if it's pi, because you remember the graph. The values you get from the graph for the interval where these triangles exist, or the angles in these triangles exist, should be the same as the ones you get in the graph. But it's harder to tell what the angle is from the graph, so I rather use the triangles for the small angles and then use the graphs for the large angles. Okay, let's get to this. Firstly, I'll do all the ones that require the triangle, and then I'll do the ones that require the graphs afterwards. The ones that require the triangle, you have sine pi by 6. Sine pi by 6. Pi by 6 exists in the triangle that has 1, a square root of 3, and a hypotenuse of 2. The opposite side, since it's sine, is the shorter side, since it's the smaller angle between this and pi by 3. Therefore, the shorter side should be 1, and the answer is 1 over 2. And then we have this. As soon as we see pi by 4, we know that the answer is 1 over square root of 2. And then we have pi by 3. It exists in the same triangle as this, but now the opposite side has to be the longer side, because this is the larger angle. The longer side is square root of 3. Therefore, that's going to be square root of 3 divided by 2. Then we have sine pi by 2. I get this from the graph. I get all of these from the graph, so we'll do them after, focusing on the triangles for now. This is how you get the ones from the triangle. And then we go to cos. For cosine, you have pi divided by 6. Pi by 6 is the shorter angle. Now let's make this a bit faster. It's the shorter angle. That means the adjacent side should be the longer side, right? The longer side. So it should be square root of 3 divided by 2, because the hypotenuse doesn't change. So basically, another thing you can, okay, no, never mind. Cos pi by 4, as soon as you see pi by 4, you know if it's cos or sine, it has to be 1 over square root of 2. And then we have cos pi by 3. This is the larger angle, so the adjacent side has to be the shorter side. That's 1 divided by 2. This is cos pi by 2. I get this from the graph, so we are going to do this later. Now we come to tan. We have pi by 6. Pi divided by 6 is, you imagine the triangle. You say the opposite side should be the shorter side, because this is a smaller angle. That means the opposite side is 1. The adjacent side is the other side you haven't counted that is not the hypotenuse. Therefore, that's square root of 3, right? And then you say tan pi by 4. That should be 1, because you know that sine of this divided by cos of this is the same thing divided by the same thing, which is 1 over root 2 divided by 1 over root 2, which is 1. But you can also remember the graph, about the triangle. The opposite side is 1, the adjacent side is 1, therefore the answer is 1. Tan pi by 3. Tan pi by 3, you have, is basically the inverse of this. But if you imagine it from the triangle, the opposite side has to be the longer side, because this is the larger angle. So the opposite side has to be, has to be square root of 3. And then the adjacent side has to be 1. But then if you divide by 1, it's the same as, you don't need to write it. Okay, now I hope you understand all those. This is how you do them. These are your answers. Now let's go to the ones that require the graphs for me. Sine pi by 2 is at a quarter of the sine graph. At a quarter of the sine graph, the graph is at the top. It's at the maximum. So the value, the answer is 1. You can see it here. Here. At pi by 2, it's at a maximum. So sine pi by 2 is 1. Sine pi is at the halfway point between 0 and 2 pi. And at the halfway point, the sine graph goes up, it goes to 0 at the halfway point, and then it goes down and goes up again. So at pi, the sine graph is 0. You can see it here again. At pi, the sine graph is 0. At 3 pi by 2, this almost the same thing as here is happening, but it's happening at the bottom. So at 3 pi by 2, it's at a minimum. It's at the lowest point. So that's minus 1. And at 2 pi, it goes back to 0, because it goes like that, and it goes to the minimum at 3 pi by 2. Then it climbs up to 0 at 2 pi. Now, cos pi by 2. Cos starts at the top, it goes down, and at a quarter of the period, it's actually at 0. So you can see it here, pi by 2. At a quarter, it's at 0. Then a quarter of the period. Then cos pi, it's at a minimum at pi. You just imagine the graph. Halfway point, minimum, minus 1. 3 pi theta, 3 pi by 2. This is almost the same as the other one. Where's the other one? There's this one. Because this is 3 pi by 2. The cosine graph goes down. It reaches 0, goes to negative 1, and climbs up again and reaches 0. So here, it's at 0 again. At 2 pi, it's at the last point. The last point is at the highest point possible, so it's 1. Then we go to tan pi by 2. I didn't draw the graph for tan, but there's mostly one important thing about tan. Okay, a lot of important things, but one that I'm going to refer to. This is the sine graph. And then here, it's 2 pi. At the halfway point is pi. Here it's pi by 2. Here it's 3 pi by 2. 0. Okay, now you know that at pi by 2, 3 pi by 2, they're asymptotes, right? If you know how to draw the graph, you will know that at pi by 2 and 3 pi by 2 there are asymptotes. You can imagine it. You don't need to always draw it. You can imagine the graph and know there's an asymptote there. So we know that at pi by 2 there's an asymptote, which means it's undefined here. And 3 pi by 2 undefined. Then we have tan pi and tan pi by tan 2 pi. Right. Now at pi you can see it's 0, né? And at 2 pi you can see it's 0. So yeah, it's 0, it's 0. You can set the center point